In this video, we will use the limit definition of derivative to compute the derivative of 5x squared minus 7x plus 3. First, we'll start by writing down the derivative, and then we can think about plugging in x plus h for all the x's, and then writing down f of x and kind of working through this. So when I evaluate f of x plus h, I need to take the x plus h and plug that in for all my inputs in the function. So first, I need to take 5 times my input squared minus 7 times the input plus 3. And that whole thing will be the f of x plus h. Then from that, I need to write down f of x. So I'm just going to copy down 5x squared minus 7x plus 3. And all of that is divided by, take a moment to notice the notation. I've used an equal sign to indicate I am going to write an equivalent expression. I've carefully used my parentheses to make sure it's clear what I'm doing. Again, this first term is f of x plus h, and the last term is f of x. Next, I start expanding and simplifying. First, I expanded the binomial, and then I distributed the negative 7, kept the 3, and then here I distributed the negative sign. Take a look at that very carefully. A lot of mistakes happen in that step. Okay, now we can distribute the 5 and just copy everything else down. Now I'm going to start looking for like terms. So I notice I have a negative 3 and a positive 3. I have a positive 7x and a minus 7x. And I have a negative 5x squared and a positive 5x squared. After I cancel all the like terms, what remains is the limit as h goes to 0. We have a 10xh. We have a 5h squared, and we have a minus 7h. Everything else should subtract out. In general, if you get to the stage and you have a term that's a constant floating around out there, you probably made a mistake. Usually what happens is every term has an h in it at this stage. So just go back and double check your parentheses, double check your algebra. I'm going to factor an h out of the numerator, just doing this step very carefully. So I get h times the quantity 10x plus 5h minus 7, all divided by h. Now it's easy to be confident and safely cancel those h's. This leaves me with the limit as h approaches 0 of 10x plus 5h minus 7. And once I substitute in, we are left with 10x minus 7. So what we're saying is that the derivative of 5x squared minus 7x plus 3 is 10x minus 7.